Regina Urazmanova, our product manager, and Oleksandr Kryvoshein, our senior researcher. Guys, please say hi to everyone.
Hello.
Yeah, hi guys.
Hi guys.
Hi. So yeah, we're pretty excited to have this journey together with you. And let me introduce the agenda of our today's webinar. So just to give you an idea, so we will be starting with a short introduction on EOSDA and basically our journey. So how do we end up being here where we are right now? And then the main part will be dedicated to the productivity maps and precisely the methodology and the patent itself, how we kind of obtained it and what we are using this from. So using the algorithm on a day-to-day basis, the algorithm's main task together with the target audience that we're trying to grasp to actually make the utmost of what we can offer. And as well, we will talk about the productivity maps in the crop monitoring platform of ours, about the VRI maps and the multi-layer maps. And we will be wrapping up with a couple of words on EOSat, the first commercial agriculture-focused satellite constellation among all the companies in remote sensing. To be sure that we will be answering all the questions that you might have on the way. So let me start with just an introductory part on who are we, so why we are gathering here, and give you a couple of words about EOS Data Analytics. So we are a private health company, and we own 3 out-of-box products that are based on satellite data and satellite data elaboration. So we were born in the United States, and our headquarters is located in California, but we do have as well the research center in Eastern Europe. We have a company of around 200 employees and growing. We have a full cycle because we are managing both the software part and also the research and development part, thankfully to our PhD engineers who are working on artificial intelligence models that can respond to any in-depth questions related to agribusiness. And so we are partnering with various governmental, commercial, and scientific organizations to provide the diverse solutions and the software in business, in different science division and education using Earth observation data. And we are operating worldwide, covering the whole Earth. And we are pretty, let's say, flexible and turning around. And we have our sales team located in North America and Eastern Europe. Seeing a lot of greetings once again. Hi, everyone. Thank you so much for being with us. Our journey, just a couple of words on that. So we were starting in 2015, and the company of EOSDA was founded by Max Polakov. And starting from there, we were introducing year by year our platforms one by one. So the first one in 2016 was the land viewer, so on the fly, real time Earth observation, imagery processing, and analytics service, followed by crop monitoring, our pioneer basically on the field parcel data solution. So like precision agriculture, everything that's related to the monitoring of the fields and responding to any kind of questions that you might have regarding your crops and the health condition of the land with which you're working. And then after that, we were dividing and developing unique in-depth learning artificial intelligence-based models. So in there, we started working with classification of the crops, the clusterization, working with soil moisture in depth, and be able even to predict the yield and to give you the estimation on how much you can actually get from the field of yours. And the last, but I mean, this is just another start of our story, is that when we decided that we want to be even more independent, and we have successfully launched our first own satellite. So it's EOSat-1 that was launched on January of this year. It's currently successfully being on the LEO orbit, and it's the first, but out of the 7 satellites of our personal constellation, that's going to be 100% agri-focused. So, concluding with this, I would be glad to pass the word to my colleague Regina, and she will be telling you a bit more about the usage of the algorithm we want to present to you today. Regina, you're with us.
Yep, sure. Thank you, Lidiia. I will continue. Hi, everyone, one more time. I'm Regina. I'm EOSDA product manager. I started work with productivity maps more than 2 years ago. I was like the owner of this feature, and today it's really big pleasure to explain you how we work with that, what is that, how you can use it. So let's start. First of all, I would like to explain a bit about algorithm. So the algorithm main task is to identify field productivity zones. We do it with NDVI index, and we analyze NDVI index in the fields during the selected period. We do huge calculations inside, but in general, what you can see as result is a variable rate application map. And I will tell more how we can use it. So the main use cases is creation of variable rate application maps. And second one is determining historical productivity. And here in the slide, you can see how the map looks like. So red zones is show us that they're less productive zones, and the green one there is more productive. So let's go deeper. Let's talk about variable rate application maps, how we can use it. So first of all, we can use it for differential potassium phosphorus fertilizer application, because this type of fertilizers should be used for huge time. If we compare with nitrogen fertilizers, for nitrogen, we just need making maps today, and tomorrow we have to apply fertilizers. But with potassium phosphorus, the situation quite different. So we need to analyze our field for a long period of time to understand which zones how productive, and then put potassium phosphorus fertilizers. Also, it can be used for seeding. For example, if the farmer understands that one of the part of the field is more productive than another one, maybe it makes sense to put that productive part more seedings and get more yield. And the same is the case as fertilizers. If, for example, user can understand that in red zones, the less productive zones, there are no reason for that. Maybe it makes sense to put there more fertilizers and make the fields like quite the same. And also soil sampling. We can use variable rate applications for soil sampling because usually, of course, it depends country to country. But in general, the idea of soil sampling is to make a grid and take soil samplings like randomly. But the idea use variable rate application like productivity maps is to take soil samplings based on the zones. I will tell about this a bit later, and I will show you how it looks like. Second one, how we can use our patented productivity maps algorithm is determining historical productivity. It's really important for that type of customers who don't own the field, and it's how to say we can use algorithm just with knowledge where the field located. We don't need knowing crops. We don't need field activities, other stuff. We just need to understand where the field located, and our algorithm can calculate the productivity of the field. So it's really crucial and important for that kind of customers who don't own the field, who don't know, who don't have this data, but they can use this algorithm and can understand what's going on with the field. For example, if some company would like to buy the fields, the territory, they can previously analyze this territory and understand which part of the territory are productive more and less, and then make decision about this field. Next one, let's talk about target audience. During my slides, I mentioned farmers, of course, for sure, farmers, one of the, I would say, main target audience, but not only them. Input suppliers, we have customers input suppliers, so it's really common usage of productivity maps. This algorithm helps input suppliers to showcase their products and understand how it works for themselves. So they can use productivity maps as a baseline and then make decisions and show how the products works. So they can use their products in less productive zones on the field and then make the fields the same. Yeah, so this one of the usage. And next type, it's food producers and agronomists. I would say they're the same, interested in getting more harvest as a farmers. So here's nothing new. Insurance sector is an interesting one. Field productivity data empowers insurance companies to make informed decisions and minimize risks. I would highlight risk assessment because for insurance companies, it's really important to understand the risk, what happens. It's important to analyze the territory with highest risk potential and make decision about coverage or other stuff make on this data. Soil testing laboratories, one more time, their use case mostly is smart sampling, not just don't take the random soil samplings across entire fields. Makes sense to do it, take it in productive zones. And so it makes the results of the laboratory is more accurate. And banking sector, it's quite the same with insurance sector because one of the use case is risk management. It's important for banks to understand which territory are high risky, which is not. But also, as I know, as our customers share this knowledge with us, for banks, it's really important to help their customers. So sometimes banks also analyze the fields and show this data to their customers, so the customers can make the field activity more accurate and get more yield. And here I would like to pass my word to Lidiia.
Hi everyone, back here again. So yeah, thank you so much, Regina, for introducing to various, let's say, verticals with which it can be applied. But I would like to dive into a very particular use case, let's say, because I myself, I'm having a master's degree in viticulture and winemaking. So I'm kind of closer to that part, and I'm very close with the viticulture, and so how the VRI maps are important for the viticulture, how they can help producers to benefit in a pretty applied, let's say, usage of the zoning. So we all know that in case we're talking about wine production, the vineyard zoning is one of the most important things, because even the slight variation of basically the soil composition, the microclimate, the things that are changing inside, it actually plays the role, and it actually influences the final product, the wine that can be made from that. So taking that into consideration, we realize how important it is to have those zones separated as well within their possibility to be able to gain the force and to have this representation. And moreover, as a second point, it actually helps to compile with like some kind of a compliance, because we know that the wine world is divided to the new world and old world. And in case we're talking about the old world, there's a lot of legislations and there's a lot of things related to the protected geographical areas that they have various lists of the requirements which needs to be met in order to be able to name, for example, the final product, the wine, as if of the denomination of a region of a certain geographical zone. So in here, using that approach of ours with this possibility of zoning actually helps to compile better with those requirements, and it helps as well to be more flexible and gain that adaptability, taking into consideration as well such things as the global warming and basically the changements in the climate. So yeah, this precisely look that you are looking at right now. So this is a crop monitoring vegetation map with a variable rate application at the vineyard in France. So you can see it's very visually remarkable how different are those zones, and maybe that will definitely help the winemaker to make a right decision about the application of the fertilizer further on. I'm very grateful to see the activity in the chat, and it means that you're active, you're with us. And taking that into consideration, we would like to add a bit of the activity. So not only us will be saying and sharing our expertise with you, but we want to start a super short quiz. So there will be just a couple of questions. You will need to select one point basically to respond. And in here, so we have around 2-3 minutes. And please look at the questions. So the first one is, have you actually heard of EOSDA in before? There's a single answer, so it's pretty easy. And yeah, the second one will be is, how important do you think the web-based productivity maps are for agriculture? We're talking about the agriculture in general. So in there's 3 answers. Once again, please, besides voting, you also can share your opinions and your thoughts in the chat. We will be very glad to hear that and to see what you're thinking. And the third question in here in this section is, are you currently using any web-based tools or application for the field productivity analysis? And wow, it's very interesting because a lot of you are actually indicating that you do. So we're curious as well about that. So in case you might share them as well in the chat, what you're currently using. Are you searching for something new? The more information we gain, the merrier we're going to be. And yeah. So I can see that within the progress that we're making, there's more than half of the participants who have voted. So I'm really hoping that by the time, it's just like half of the time that we're spending on this is off. So let's wait a bit more. Yeah, and thank you so much once again for being with us and for being active. I've seen so many comments from you being from all around the world. It's just phenomenal. This is really great. Yeah, and please don't forget that in case you will have any extra questions that might be not just related to the zoning and variable application maps that we're discussing today, feel free to reach out to us. We are leaving pretty much all the emails where you can contact us, and we will be glad to work with that. So as far as I can see, our time is up. So let us see what kind of results we are getting in here. So the average point is, yeah, so we have 63% of people who have voted. I'm glad to hear that and to see that. So more of you have actually seen and have actually heard that about the EOSDA before, which is good, but I'm also excited for those ones who is hearing for us about us for the first time. So it's a pleasure to meet you, and I really hope that we will get the chance to get each other even in more details sooner. About the second question, so, oh my God, can you imagine 0 people voted that it's not important and that they don't see the value in web-based productivity best for agriculture? That's good. I mean, are convincing and the technology is convincing because it is. And yeah, I'm glad that so many percent of you are actually responding that it's very important, because it's definitely true. And the third, yeah, so in here, the distribution of the answers is also interesting because it kind of divided half and half. Still, more of the people have voted that they're using the web-based tools right now. But for those who are not using it, I'm really hoping that after our webinar, you will get a bit more of the questions. You'll probably be interested in trying out our trial version of the crop monitoring to test how to create those variable application maps yourself. So thank you so much for participating. I think we can wrap it up with this and start once again with the presentation. So I'm handing over the words once again to my colleagues, and we'll talk about the algorithms, fast and easy usage in crop monitoring. Regina, you're back.
Yeah, thank you. The results of the questions is pretty interesting, I would say, and I'm really glad that nobody thinks that the technologies are not worth it. And let's continue with our presentation. This will be my second part. I would say how to use our algorithm easy and fast in crop monitoring. For sure, our algorithm can be used as API and everything else. But if you would like to try it just right now, you just should go to crop monitoring, and there you will find the section zoning and productivity maps, and just try in your fields. It's really easy, and I will tell how to easy it is. So the main parameters is just two of them. It's number of years and number of zones. Number of years, you're able to choose since 2016, because we use for this algorithm in crop monitoring Sentinel-2 images, and the satellite provides images just from 2016. But actually, it's pretty a lot. So, it's pretty enough years for doing algorithm. There are some rules. If, for example, you use it in the start of the year, there are no season, we ask to not check, don't select this box of the year. So you can see in the slide 2023 we didn't select. And also, if you know that in your field some year were no season at all, no vegetation, you also can exclude this checkbox, and this will make it will make map more accurate. And second parameter is number of zones. If you have never met variable rate application maps, you for sure see it is number of zones which the map will split up in the end. So we're allowed to choose from 2 to 7, but usually people use, like our customers and farmers and standards, I don't know, use like 3 or 5 zones. After selected parameters, you just have to click calculate, and it takes around 30 seconds. And actually 30 seconds, it's not that much time, because during this time, algorithm analyze all these years, all this time and images, pixels, everything, and create maps. And it just takes 30 seconds. So 30 seconds for that case is not that much of the time. You can see in the slide, you will get the map, you can see it, and then in the right you have the inputs where you can write amount of seeds or fertilizers you would like to put in your fields. And pretty that's all. You just click export, and in crop monitoring you can export the files as shape files or XML files, is like two of the common formats for agri-machinery. And then upload this file to agri-machinery, and agri-machinery will put the amount of fertilizers you wrote in this program to the field. And also you can use this map, as I mentioned before, with soil sampling. And so you can see in the left, soil sampling is usually it's like a grid. Just we have a grid in the field and put the points of soil samples. But you can see in the right that it makes sense to take the soil sampling based on this data. So it makes sense to not just randomly using the grid. It makes sense to take soil samples during this with the zones. Yeah, and last one with my part, I would like to explain you about multi-layer maps. It's kind of spoiler, because currently we are working on this algorithm. So multi-layer maps, it's a new feature where the user can mix moisture, vegetation mix, and elevation maps. In the future iterations, we will add their productivity maps, and it allows you to understand why the zone productivity is like that. For example, if we have the layer as productivity map, and then we have a layer of elevation map, and we can compare in one feature and understand, is this productivity of the zone productivity like this because of the elevation or not, and then using this knowledge for creation map application. For example, I heard about use case when sometimes maybe it makes sense to put more fertilizer in a hill because the fertilizer will go down, or maybe it makes sense not put fertilizer on a hill at all because there are no vegetation. So of course, it depends on the fields, it depends on the climate and soil, but in general, this tool will help users to understand what's going on in the fields and how it works. So keep tuned with this feature. We will release this in next month. And that's all from my part. Thank you very much for attention, and I will pass my word to my colleague Oleksandr.
Hello, everyone. Again, my name is Oleksandr. I'm a senior researcher at EOSDA company, and today I will tell you about some ways of how can we use this our new product, how this product can be enhanced. In order to consider the local factors in the field, it is proposed to use high-resolution satellite data that allows us to see the local variations in the development of crops using vegetation indices. These indices characterize the distribution of above-ground biomass production over the field. Among the large number of vegetation indices, NDVI is the most simple and widely used. And previous studies have demonstrated that the relationship between satellite-derived NDVI and ground biomass productivity. And our assumption in the analysis of satellite data, according to our historical productivity index, is based on the fact that biomass indirectly characterizes the cumulative effect of local factors, variation in the soil characteristics, topography, and sometimes even local severe weather impact. And based on this assumption, our algorithm helps to estimate the potential of arable land at the field level or in the large areas with a spatial resolution of 10 meters, 30 meters, or 500 meters. It depends on the satellite data we use. The long-term productivity index or historical productivity index is quite informative for determining areas of high and low fertility in the agricultural field. And farmers can use this index before sowing for better field management in the future, or prior to the field purchase. For example, when farmers considering whether to buy or not to buy some fields or areas, they can take a look at the region of interest through this index. Okay, what does algorithm do? Simply speaking, we can allocate several steps. Collect all cloudless images within region of interest. Stratify images by years. Get rid of noise or outliers. Combine results through some averaging techniques. And clusterize final results. How this algorithm can be enhanced and where it could be used. There are many ways, and my colleague Regina has already showed some of them. But now we're going to show you the couple of another ones. And of course, no less important. The estimation of crop potential and initial content of soil organic carbon. Yes, the output of algorithm can be the basis for specific index calculation, so-called CALPI, or Combined Arable Land Productivity Index. And let's take a look in it in more detail. Sometimes farmers want to know about their field's potential not only in dimensionless units. As you know, most vegetation indices are in dimensionless units, but farmers want to know about the field potential in units of yield. In other words, the question is how to assess the crop potential in some area of interest in respect to units of yield in kilograms per hectare or tons per hectare. And in order to answer this question, we can use the CALPI, which is a combination of historical productivity index and biophysical model result. Based on this index, we can give insight on the growing potential of main crops in a given field or region. So, as was mentioned before, the CALPI index consists from two main components. First, historical productivity index, and second, biophysical model results. And now let me briefly describe the second component, biophysical model. In order to estimate and simulate the total above ground production and storage organs, we usually use the Bofrost model. This model describes the main processes in agro-ecosystem, such as photosynthesis, respiration, assimilation, partitioning, and so on. On the slide, you can see the simple scheme of Bofrost. From the observed radiation and the photosynthetic characteristic of single leaves, the daily CO2 crop assimilation rate is calculated, so-called potential gross assimilation, potential gross photosynthesis. Part of the carbohydrates produced are used to provide energy for maintenance of existing leaf biomass, maintenance respiration process. Remaining carbohydrates are converted in structural matter. During this process, some weight is lost due to gross respiration. And all these processes the Bofrost can describe. Okay. Here you can see the main input and output data in Bofrost model. Input data are meteorological, phenology, crop, and soil data. The output are the following productivity parameters: total above ground production, storage organ, leaf area index, total water requirement, total water consumption, relative soil moisture, and soil moisture in root zone. And the storage organ parameter reveals the potential biological yield, and this parameter we used to calculate our CALPI index. One of the basic steps prior to use biophysical model is model calibration. There are many techniques and methods to do this, but we usually use leaf area index assimilation technique. What we do, we calibrate specific crop parameters in the model until to get the output leaf area index curve, which is closest to satellite-derived leaf area index curve. And after this calibration, we can apply our model to the region of interest. Okay, this is a brief scheme of CALPI calculation. The upper flow related to historical index productivity. The green circle steps related to biophysical modeling. At the final, the steps number 3 and step number 6 are combined and we generate CALPI. Let me show some results of CALPI. This slide shows the results of CALPI in a big area for soybean and maize. You can clearly see that for maize, the potential of this area at the eastern part is pretty lower compared to the western part. And this is certain what customer expected to see. In other words, these results have proved the user's anticipation. Here another example of CALPI results. As you can see, almost whole area is homogeneous for soybean growing, but for maize potential, we can observe the great contrast. The western part of this area of interest potentially can produce about 10 times more yield compared to the eastern part. So this is really very informative. Again, as you can see, CALPI is really very useful for estimation of crop potential in the units of yield. Okay, as was mentioned before, another effective way of using our historical productivity maps is to improve the accuracy in determination of soil organic carbon content or soil carbon sequestration process. Just for your awareness, soil carbon sequestration is one of the most cost-effective and impactful strategies which help to mitigate climate change, preserve soil fertility, and helps to avoid food demand crisis. In order to estimate the soil organic carbon in the next, for example, 5 years, we have to use specific process-oriented model or process-based model. And one of the main input parameters of that model is current or initial soil organic carbon content. And as a rule, to get the best or high accurate initial SOC, soil organic carbon, we need the actual data from the fields, which are very expensive. And the solution is to collect samples as much as possible and then use machine learning model. And this is the point where the historical productivity index is very useful as main predictors. So we use our historical map as predictors in machine learning models along with actual samples. Here's a simple scheme of process-oriented SOC prediction model, role C. At the left side, you can see the main input parameters. On the other side, the output of model expressed in soil organic carbon content in the next 5 years under different agro-management practices. So one more time, the initial SOC, one of the main input parameters, and these parameters can be clarified by historical productivity index. And to sum it up, our productivity map or historical productivity map or historical productivity index is really useful and informative parameters that can be used in many ways to improve agro-meteorology strategy, soil fertility determination, field management, soil carbon sequestration, and even mitigation of climate change. This is it from my side. Thank you for your attention, and I pass my word to Lidiia.
Oleksandr, thank you so much. That was a great explanation. Thankful for everyone who is once again with us. And here is another time for another quiz action. So right now you'll be seeing some more questions to be answered. The rules remain the same, so we'll have 3 minutes to respond them. And please take a look at this block number 2. So the first question goes, are you currently using EOSDA platform tools? Attention, for field productivity analysis, and you're saying either yes, you're using EOSDA crop monitoring tools for field productivity analysis, no, and you are using other platform to monitor your fields. Please select one that's relating the most to you. And then just to give you some heads up on the question number 2, there are even more answers to go. So what features do you consider essential in a web-based productivity map? So once again, single choice, real-time data updates, accurate and detailed field productivity metrics, user-friendly interface and intuitive navigation, integration with other agriculture management systems, or other. In case you're specifying other, please don't hesitate as well to compile your answer within some comments in the chat, so we will know what you actually were meaning. And the third question in here is how likely you are to consider incorporating EOSDA web-based productivity maps into your agriculture operations. So we would like to know either highly likely because you believe it could significantly benefit your operations, moderately likely as you will need some more information before making a decision, and it's going to be really good because like this, we will be having once again another opportunity to meet up again and to discuss the projects in detail. And no, you're currently satisfied with the current matters that you are using. So 3 questions, just one choice, please be active. Let us see how much time we got left. So it's around 45 seconds. For now, we got around 43. Let's make it at least 50% of people who voted. Come on. Just a bit of time, just 3 clicks, and we'll be ready to continue. It's just a bit of a time that's left. So let's see. Yeah. And definitely after that, we will be already on our finishing line to tell you a bit more about the EOSat and the details about the constellation of our satellites. And then we will be passing over to the Q&A session. So one of the most exciting parts, actually. Awesome. Okay, so I'm really grateful because you've made my wish come true. So you've made more than the 50% of the people who voted. There was around a very nice response rate, around 60%, which is great. And yeah, it is very interesting that a lot of you have answered that you are not using any web-based tools for field productivity analysis right now. So this means that this webinar is actually was in the right place to be, because this means that we will have some more chances to tell you more, to convince you, and to make you see how that's working and that it actually brings some results. So in terms of the features that you consider essential, let's see what very interesting. There are 2 answers. So the real-time data updates and the accurate and detailed field productivity metrics are the leaders, the pioneers. And in the 3rd place, we have the integration with other agriculture management systems. That's really interesting. I mean, I'm dealing with talking with the prospects pretty much every day, and I realize how it's important sometimes for them when you're having your own solution in place and you would like to be able to combine that with other solutions. And nice results in here as well. So the leading answer for how likely you are considering incorporating EOSDA web-based productivity maps, the high likely results is on the top. So I'm pleased to see that. This is amazing. And definitely, once again, we'll be happy to answer all the questions of yours and to tell you more about that. So you will see how that works in real life. Thank you so much for participating. Once again, I think we can get back to our presentation. And there's this final part I'm going to be taking over. So we're going to tell you a bit more about the EOSat. So the first world's Agri-Focused satellite constellation among all the companies that are working with remote sensing. So just to introduce to you, basically it was a very long way, and it's still kind of a long way to go in plus, but within our years of an experience, within starting in 2015, by 2020, we have managed to gather so many particular requests based on the agro demands of our potential customers and actual customers, that we realized that using the classical approaches, using the public available information, satellites, is not always enough. So after precise work on different questions that might be requiring any kind of elaboration, plus we've decided to come up with this design, with this idea to create the first ever satellite specialized solely in agriculture. Each and every of our satellite, of 7 of them actually, are having specialized bands that are helping to go into in-depth details of various vegetation indices on all the things related to the soil moisture, to understand what's kind of hiding behind of all of that story. And our sun-synchronous orbits will have the 5-6 day visit rate to cover all the agriculture regions, but we are targeting by the time of the compilation of the constellation to achieve the 24 hours revisiting time every single day of the tasking on the fields. So the first tests were actually performed in 2021, and in 2023 we finally luckily managed to compile a successful launch, and right now our EOSat-1 is already on the LEO orbit, as I've mentioned before, and in the near future we're planning the launching of next 6 EOS satellite, and we're hoping to achieve that full operation capability. Going more into details on the EOSat as well. So it's our own built high quality imagery and data for agri-power purposes. So the satellite is flying around the Earth. It's receiving the information also, like the stations that are being on the processing powers, and we have a specifically dedicated team that is working right now with it. So the team of skilled space scientists and engineers, together with the team of R&D scientists and data engineers and agronomists, are collaborating to present you the outcome, which will be the high quality and accurate business insights. And once again, thank you so much for being with us. I think that on this note, we will be, because I've also seen that there was some kind of a questions regarding the EOSat precisely. Let's then move towards to the Q&A session. So like this, we will have enough time to satisfy all the questions that you have posed. So I think that probably Regina, Oleksandr, there were some initial questions that I think that you will be helping to respond. Please join me.
Yeah, thank you for questions. I would like to respond for 2 of them. First of all, what I saw and related to me. So first question was, we are currently using EOSDA NDVI tiles via API. Is there or will there be an API for Varia Maps tiles? Yes, it already exists. If you would like to use Varia Maps vegetation or productivity maps from crop monitoring through the API, it exists. You can just write us and we will provide you more information about it. And also, I found another question I can reply. I have been using the software, but haven't received images for more than couples of weeks. You say the site was covered with clouds. How are you planning to facilitate the monitoring during monsoon? So this question is not about Varia Maps. Crop monitoring also provides information as just monitoring tools, so you can understand what's going on in the field right now. And we have add-on with high-res images. So with these high-res images, you can see first of all high-res images, and the data of monitoring will be more precise. And second, these high-res images, they are really often. So if Sentinel images you can see like once in 3-5 days, these high-res images you can see every day, and maybe sometimes in one day. Yeah, so this is add-on will help you probably to get to resolve this issue. At least it's a good idea to try how it works. Yeah, this is from my side. If you have a question to me, please ask. And I saw another question, Lidiia, about tomato. Maybe you can help here.
Yes, here I am back. Yeah, so I've seen the question regarding do we have actually someone we're working on tomato productions? And the answer is yes. Actually, one of the biggest producers in the United States, Morningstar, are our client, and they're successfully monitoring more than 10,000 hectares of their production. And one of their main goals was, by the way, it's kind of related to one of the questions that we have posed to you earlier, and you've indicated that it's kind of important. So they're actually being able to combine our platform and the results from our platform together with what they're doing for their development. So yeah, this is, and also in the same blog, I was actually seeing some questions on, let me just check. Yeah, there are so many questions, but we're really grateful that you are working and that you are actually posing them. So can you tell us, please, when you expect sample data from EOSat 1 to be available? So first things first, we have recently even issued an article when actually the first imagery from EOSat 1 was obtained. I believe that my colleagues will be able to maybe share the link after the webinar, or maybe put it in the chat as well. So guys, in case anyone has this link, I would be really grateful in case you can share it. So right now, the beauty of the EOSat 1 is also in the way that it has the time of the revisit that came up right now for like 15-20 days, but there's the possibility to work with the imagery already. So in case you have any particular requests, and in case you have any particular tasks that you would like to monitor with our EOSat 1, we have this exclusive opportunity to actually work with that data, and we will be very glad to help. So please reach out in case you might be interested. I and my colleagues from the sales department, we will be super glad to answer those questions and to guide you through the information we might be needing from your side to make you the right offer. And yeah, so there was a question number, like what GSD would you expect to see, and what level of cloud cover can EOSDA satellite penetrate? It's a combined question, so there are a couple of things that I would like to highlight on that. Let's start with the first. So basically, the EOSat 1 has the resolution like multispectral panchromatic, which is like in the multispectral will arrive to 1.5 meters per pixel, which is kind of revolutionary comparing even to the satellites that are being floating right now. Because in case we're going to take it's in comparison with the Sentinel-2, it has 10 by 10 meters. So 1.5 is definitely I would call it revolutionary. So yes, and in terms of the cloud cover, so there are several things on which I can elaborate. So we have the crop monitoring platform right now, and inside of the crop monitoring platform, there is already a thing that is called the cloud masking that's been incorporated, and it's already in use. It's meaning that even though sometimes there's a certain amount of the cloudiness, or there are some clouds that are appearing on the field, Our system makes the elaboration of the data in that way that it eliminates the effect of white, and so basically the readings of the NDVI or any other vegetation indices is still kind of corrected. So this is the first thing to address this question. Of course, there is also the possibility inside of the crop monitoring platform to select the level upon which you would be accepting the imagery with the clouds. So it's also kind of one of the possibilities. And regarding the new features that are about to come. So within the EOSat constellation and the combination between the Sentinel-2 imagery and EOSat, we will be able to create so-called golden standard of Sentinel, meaning that even in the cloudy days, whenever there will be, some specific clouds, there will be a possibility to restore, based on artificial intelligence model, the readings of the vegetation indices. So this is something that definitely up to come yet, but that it's going to be pretty shortly outgoing, and we'll be able to produce on that a bit more. I know that there is some more questions. I think my colleagues will be, guys, Oleksandr, Regina, please help me with those questions that were not covered yet. So let's see.
Okay, let's. I will answer for one question or just comment, and then just pass my word to Oleksandr. So I found here I'm a PhD student, and he's working on developing models for plant disease identification. And he's wondering if we have published available data that could assist me in my research. I'm not sure about public available data. I mean, we have for crop monitoring, we have data in the field, and we have free package, so you can try and understand what you need there. Do you have it there? But actually, we are working on our disease model, in the identification model. So if you're interested maybe in collaboration or anything else, you can contact us because we're also working on that. Yeah, Oleksandr?
Yes, this is the questions about, I think, how do you collect soil moisture data from SATs? What sensors? As a rule, we use the RMSR data and SWOT satellite data. And also we use our own model to simulate the soil moisture content. The model is the same workforce model, can provide such kind of data, and Hydrus model also can provide such data. So we use satellite and we use process-based model, which can provide such kind of data at the different layers of soil, 5 centimeters, 10, 30, and stratified by 10 centimeters in deep of the soil. And I tried to find the other questions. Lidiia, can you help me with the questions we still not cover?
Yes, Oleksandr, I'm here with you on that. Let's see together, because there were so many that they were, chaotically we're responding them. So
is there any tool for groundwater monitoring? It's the questions regarding to soil moisture, or can you clarify? I mean, the people, the man who writes this question, can you clarify, please? What water you mean? You mean soil moisture or just river and etc.?
yeah, and I believe that there was some question, I think, regarding the relation between the company and NASA EOS program. I'm not sure if we have covered that. I think I've misheard probably.
Yes, I see in the chat, in our chat, that here I'm organic farming console, can this product used in mixed farming? I thought that Lidiia, you already covered this question. If you provide the data of which kind of crops in the farming, we can prepare our model and simulate biomass to these crops, and then combine it with our productivity index and provide you the results in crop yield.
Mm-hmm.
In crop yield units, okay. And
Yeah, I found another question. How many years of data do you have to analyze? We have really different type of data, and it depends on them. Because, for example, if we're talking about satellite data, as I mentioned before, we can analyze it since 2016, only because satellite Sentinel was launched in that year. But if we talk about weather data, we have it more and more years. So we need to understand which type of data do you need, and we can answer more precise.
Yeah, and I think there was another, I would need to clarify on the resolution of EOSat, because there was a confusion that was from my side, my apologies. So the panchromatic is 1.4 meters and multispectral is 2.8 meters. So
yes, panchromatic bands 1.5 meters and 3 meters multispectral. And after launch the whole constellation, the temporal resolution will really increase. It will be about 1-2 days revisit time to cover the same territory. So this is the main point of total constellation. So the spatial resolution is the same, 1.5 meter, but the temporal resolution will be increased. And the questions about monsoon, Regina, you already covered this question. Yes?
Yep. Here's a question about soil moisture data. Oleksandr, maybe a comment. Which sensor do we use for that?
The RMSR data, the satellite data, and as a rule, and SWAT, SMAP data, and different process-based models. Yes, WOFOS can provide the soil moisture and Hydros provide soil moisture. So we use our meteorological data in this model and simulate the soil moisture content. And also we use Sentinel-1 data. So, but basically this is a combination of RMSR, second, and process-based models.
Okay, thank you.
I actually think that we've covered all the questions as far as I can see.
Yeah, here.
In case there are any other questions, guys, just don't hesitate to, still have some time. So please be active. And in any case, what we've been saying is that we will be definitely glad to know you more in person, the attendees and people who participated. So in case you will have any extra questions or any extra things that we would like to elaborate us on, we will be more than glad to organize another session with you, or like a call, and to get to know your projects. Yeah, Regina, sorry, I think I've interrupted you.
No, it's fine. I just read the comments, and it's really thank you for all your questions. And someone clarifies satellite data, and I think it's about question how many years do we have of data? And we talk about satellites. So yeah, satellite data in crop monitorings, I will repeat one more time, since 2016, but we have another product, Land Viewer, and there are a lot of different types of satellites. and you can see which one and which year this was launched, and this type of this amount of data we have. Okay, maybe I think we didn't cover one more question, because it's really a huge one, but I will shortly repeat the sense of this question. So the sense how we cut our cloudless images and how we use it, and what's the territory of productivity algorithm. So the idea that yeah, if the territory is cloudy, we exclude this year. Yeah, because it doesn't make sense to count it. So we work just with vegetation season, and it makes sense. And about territory, we usually work with the fields. So yeah.
Okay, so was it the last one, do you think, Regina?
Yeah, I think so.
Perfect. Then, yeah, once again, as we've mentioned before, in case any extras that you will think maybe after the webinar, we'll be glad to face them and to answer them and to get you personally in more. So guys, just don't hesitate to reach out to us after the webinar. We are super glad that you were with us this hour. I hope that, we haven't overwhelmed you with the information. So yeah, in case you'll have to consult with us, don't hesitate to reach out. And thanks everyone once again. Thank you, Oleksandr. Thank you, Regina. Thanks as well, our moderator of the chat, Reels. It was awesome. Thank you everyone for your participation, and yeah, more to come. So definitely we'll be glad to hear more.
Thank you all.
Thank you all.
Thank you. Bye.
Great
Take
rest
care.
of the day. Thank you, everyone. It was a pleasure. Cheers.